So, good afternoon, everyone, and welcome to this class just before the biggest festival of your life, Makar Sankranti. And we are preparing for JEE Main of 2023, which is also coming after some time. Ironic it is, we are dealing with the motion of charged particle in a magnetic field, and we had seen that two special cases we had seen. What are the two special cases that we had seen? Anyone would recollect? What were the two cases that we have seen so far? Huh? No one knows it. Do we know it or not? What are the two cases that we have seen so far? No one remembers it. The first case is if the velocity is zero. Well, nothing happens, the particle remains at rest. Second case, when the angle between the velocity vector and your magnetic field is 0 or 180 degrees. Well, nothing happens there also. The third case, the case where 99% of the questions do come, is the case where theta is 90 degrees. Theta is 90 degrees, force is maximum. This force keeps on changing with time in direction, but it keeps on changing only in direction, not in magnitude. And the particle performs our old friend UCM, and we had seen the radius and the omega and frequency and time period, and also some more questions regarding this circular motion. Remember, as soon as you see what as soon as you see what as soon as you see what huh as soon as you see what as soon as you see a particle moving with a velocity in a perpendicular magnetic field, the first question that should come into your mind is that this particle is performing uniform circular motion. Do we understand this? Yes or no? Yes or no? I can hardly see anyone. Do we understand this? Yes or no? We understand this? Yes or no? Are we there, everyone, or I've lost everyone?
Sir, one minute, sir.
Yes.
There is some issue in our PC, sir.
Not a problem. So you can't hear me, you can't see me, beta?
Your screen is not visible, sir.
My screen is not visible. Now is it visible?
Yes, sir. Now it's okay.
Okay, so as soon as we understand that the motion is taking place in a perpendicular magnetic field, that must remind you of uniform circular motion. Now, as soon as you see uniform circular motion, if I tell you the value of this magnetic field is B, the mass of this charge is M, and the charge of this particle is Q. You must understand and remember that this is a uniform circular motion. Now I can name this point as A, B, C, and D. Now particle of charge Q mass M is moving in a vertical magnetic field like this. You have to tell me the time it takes to move from point A to point B and the time it takes to move from A to C. These are the two times that I'm asking. What is the time taken by the particle to go from A to B? And what is the time taken by the particle to go from A to C? I'll give you 2 minutes and wait for your answers patiently. Let me know once you are done. The time period of this uniform circular motion is 2 pi m by qb. That is the entire physics in this chapter, in this question. How much time then it will take to go from A to B? Is it so difficult? How much time it will take to go from A to B?
T/4.
Was it so difficult that you could not answer it on your own? Time taken to go from A to B will be T/4. Pi m by 2qb. What is the time taken by the particle to go from A to C?
T/2.
Was it so difficult that you could not do it? Anyways, these were the answers for this particular question. I hope we have understood this. Remember, whenever I give you a question, I only give you when I think that you can solve it. Why do I think that you can solve it? Because I have told you everything that you need to solve. The question is already known. You just need to rewind back and find out the answer from there. This is the question. In the figure shown, the magnetic field on the left of the line PQ is 0. And on the right of line, so which means this region, this green region has a uniform magnetic field B, which is going inside the plane of the paper. Find the time spent by the particle in the magnetic field. So if I elaborate it further, there is a particle which enters this magnetic field at the point A. Mass is m and charge is q. How much time does it spend inside the magnetic field? Remember, only on the green side we have magnetic field, whereas on the pink side, this side, there is nothing. There is zero, anda. There is no magnetic field. How much time will the particle spend in the magnetic field? That is the question. Do you think you can solve this? You have adequate information to solve it? Do you think you can solve it?
Yes, sir.
Then you have 2 minutes. If you think that you cannot solve it, let me know. We don't have time that we can waste. So if you think that you cannot do it, please let me know. I think you can do it. It's a simple question. You have 2 minutes to do it. So this is how the particle moves. As you can see, the angle between the particle, the velocity of the particle and B is how much? What is the angle between A and B?
90, sir.
So how is this particle going to move? How is this particle going to move? How is this particle going to move? No one knows it. It is going to move in a circular path, my dear friend. Uniform circular motion. So first of all, let us see where is the center of that circle lies. The center of the circle will lie where the force is acting. In which direction is the force acting? So U is going here. Magnetic field is inside like this. So the force will act perpendicular to U in this direction. In this direction, the force will act. And therefore, the center of the circle will be somewhere here. This O becomes the center of the circle. It is going to rotate in a uniform circular motion about this center. So the circular path will look something like this. The circular path will look something like this. I have probably made it a bit more extravagant. It is not correct.
Pyramid man. ఇంతకన్నా
It will move in a circular path just like this.
Pi m by qb, sir.
And it will come out from this point. If I just show you a better diagram, because it's very difficult to draw arc of a circle here. If I show you a better diagram, this would be a better diagram to illustrate my point. So it comes out like this. It has a center O. It comes out like this. And as you can see, it is spending half of a circle, 180 degrees inside the magnetic field. Whatever velocity it gets in, the same velocity u, but in the opposite direction it comes out. How much time does it spend? It is half of the time period, pi m by qb. That is the time it spends in the magnetic field. I can ask you more questions. If I take this as the origin of coordinates, if I take this point as the origin of coordinates, what is the point? If I call this point as point A, what is the coordinate of this point A from where it emerges out? Can you tell me that? What is the coordinate of the point A from where it emerges out? What is the coordinate of the point A from where it emerges out?
0, 2r.
0, 2r. That is correct, because this is r. From here to here it is r. This will be also r. So this will be 0, 2r. But remember, how much is r? How much is r? R is the radius of the circle, mv. Here v is u, mu by qb. That is the answer, my dear friends, that I was looking for. And that is how questions of this nature are solved. Do we understand this? How this is done?
Yes, sir.
Are you feeling confident that you can do the next question that comes in this category? Yes or no? No, yes.
Yes, sir.
Then, sir, this is the question. A similar question is there in your SCV. HCV wala thing is small, so I have to magnify it and it looks bad. So I'm just showing you it from a different source, my sheets. A positive charge particle of charge q mass m enters into a uniform magnetic field V with velocity v as shown in the figure. There is a slight difference between the previous question that we did and this question. Here it is entering at an angle. There it was entering perpendicularly. On the left hand side of PQ, there is no magnetic field, and on the right hand side of PQ, there is a uniform magnetic field B. Find number 1, time spent by the particle in this magnetic field. Number 2, distance traveled. Oh. Number 3, impulse of the magnetic force. I'll give you 2 minutes and wish you luck. I hope you can do this question. I would be very happy if you can do this. So I think you have understood the basic concept, and it's time for me to enter at this stage. Again,
Sir, distance equal to 2m d theta by qb.
think you have got the right answer. Let me just intervene and do the needful. So that was the question, and this is the well-drawn diagram. So you can see, first of all, you have to find out where is the center of the circle. That is the most important aspect here. If you can find out the center of the circle, after that, physics says bye-bye and it's all maths. So you can see velocity is here. Magnetic field is inside. And when you turn your fingers, it comes perpendicular to this magnetic field. Do we understand this? This is the velocity and this is the force. Do we understand this? So the force is going like this, hooding, hooding, hooding. Do we see this? Hooding, hooding.
Yes, sir.
This hooding is going like this. This arrow does not look good. So let me make this arrow. The force will be acting like this, and the center would lie somewhere here. This angle is 90 degrees. Yes or no?
Yes, sir.
So from there, using simple trigonometry, you can find out that this angle, smaller angle, will be 90 minus theta. So the total angle will become 2 theta. Yes or no? By simple trigonometry, you can also find out that this distance, the vertical height, will be 2r sine theta. Yes or no?
Yes, sir.
With simple trigonometry, you can also find out whatever velocity it enters, the same magnitude it comes out at the same angle. Yes or no?
Yes.
That's it. That is the answer. Now, if you have to find out the time spent, basically what you do is you multiply omega by t. It is a simple harmonic motion. It's a uniform circular motion. Omega into t
2
is
theta.
your angle, 2 theta. Yes or no? So your time simply becomes 2 theta divided by omega qb by m. That is your answer for the time spent. Yes or no?
Yes, sir.
The distance traveled is given by the length of this arc. Yes or no?
Yes, sir.
What is the length of this arc? The length of this arc is r, the radius of the circle, multiplied by 2 theta. Yes or no? And the radius of the circle is mv by qb. Do we understand this? Yes or no?
Yes, sir.
At which point it comes out if they would have asked. So this is your origin. So this point becomes how much? It becomes 0, comma 2r sine theta. Yes or no?
Yes, sir.
All plain trigonometry that we are applying. The only thing that is left is to find out the impulse of the force. Now the impulse of the force is change in momentum. So what you have to write? You have to write the initial momentum and the final momentum in vector form. If I write the final momentum pf, v is like this is theta, so you can resolve it into cos and sine. So my final momentum is minus mv sine theta into I plus mv cos theta into j. Yes or no? Do we understand the final momentum? The final velocity is like this. We have resolved this velocity into two components, this one, and multiplied it by m. Yes or no? No or yes? Do we understand this?
Yes, sir.
Similarly, your initial velocity is like this. You have to resolve it into two components. One will be like this and the other one would be like this. Yes or no? No or yes?
Yes, sir.
So your initial momentum, if I look, initial momentum will be mv sine theta into I plus mv cos theta into j. And if I have to find out the impulse, it will be final momentum minus initial momentum, and that will be minus 2 mv sine theta in I direction. Everyone understands how I have found it out?
Yes, sir.
Impulse is the change in momentum, my dear friends. I hope you remember it. That is how I have found out the change in momentum. Everyone understands this? Yes or no?
Yes, sir.
Pakka?
Papa, sir.
Okay. And congratulations. Then I can give you this question. This again is a question taken from SCV. This is the question. A uniform magnetic field B exists in a region of width D. On the left side, there is no magnetic field. On the right side of it is no magnetic field. Only between these two plates, there is magnetic field. A particle of charge Q and mass m is shot perpendicular into the magnetic field. Find the time spent by the particle in the magnetic field if D is greater than some value, if D is smaller than some value, and I'll give you 2 minutes to give me the answer for both the cases. Well, in first case, your time is over, my dear friend. I gave you enough time. Yes. Even then, I'll give you time to speak. Yes, speak.
D is equal to pi m by QB in first case.
In first case, D is equal to pi m by QB because it will be one half circle. D is more than the radius of the circular path, and it will turn half of a circle. So in the first case, the answer is very simple. Pi m by QB. Do we understand this, or this is gonna power at saying bye bye? Bye bye. Bye bye.
Understood, sir.
In the second case, what is going to happen, bacha? It is not going to complete the circular path. It will just cut. The circular path will cut what? The circular path will cut that boundary, and it will emerge out from some angle theta, at some angle theta. Do we understand this? Yes?
Yes, sir.
Or no?
Yes, sir.
Now, you just have to find out how much is this angle theta. You must understand that this is the center of the circle. Do we understand this? Yes or no? No or yes? Huh?
Yes, sir.
This distance will be equal to your R, the radius of the circle. Yes or no?
Yes, sir.
This distance is already given as D, which is the distance between the two plates. Huh? Then we can easily calculate the value of sine theta. Sine theta will be D by R. So theta will be sine inverse of D by R. Yes or no? No or yes? If you know the value of theta, then time is known because omega into T is your theta. Yes or no? This is uniform circular motion, my dear friends. So the time will be theta divided by omega, m by QB multiplied by theta. Theta is sine inverse of D by R. This is the answer that we were looking at. Do we understand this, or this has gone above our head saying bye-bye?
Understood, sir.
Anyone got these answers? Not the first one. First part was probably simpler. Did you get the answer for the second part?
No, sir.
I'll give you a minute. Note it down. If you have any problems, please ask. And then we'll move on to the next topic. Then we must move on to the next case. I think that is case number 4. Case number 4, my dear friends. Number 4 case. We have done the case where V was 0, nothing happens. We have done the case where theta was 0 or 180, nothing happens. We have done the case where theta was 90 degrees, uniform circular motion. What is the case that is remaining here? Tell me. Open your voices and tell me. Where 0 is less than theta is less than 90 degrees. So the angle between V and B, my dear friends, what? It is not 0, it is not 180, it is between 0 and 90. If it is 0 and 90, it can be between 0 and 180 apart from 90. Do we understand this? Yes or no?
Sir.
What, sir? So, my dear friends, your magnetic field, let us say, is like this, and your velocity is, let us say, like this. They are inclined to each other at an angle theta. Your magnetic field goes like this, ding, 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 and your velocity goes like this, ping, 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 ping. what type of motion this particle would have? Yes. What type of motion this particle could have? No idea?
Projectile motion.
Projectile motion comes the answer. May I ask you why? Why is this projectile motion? Or you have given the answer just because you wanted to say something? Huh? So basically, this is how the thing is. Your magnetic field is going in this direction along, let us say, x-axis. Your velocity is like this. So your velocity can be broken up into two components. One component will be v parallel and one component will be v perpendicular. Why I'm calling it parallel and perpendicular and not v cos theta and v sin theta? Because the theta could be given with b or it could be given with the y-axis also. So you understand the meaning of v parallel? V parallel is that component of velocity which is parallel to your magnetic field. Your magnetic field is like this. Do we understand this? And your v perpendicular is that velocity which is perpendicular to the magnetic field. Do we understand this?
Sir.
Now what will happen to, because of this parallel velocity? V parallel velocity will remain constant. It cannot change because it is in the same direction. Yes or no? The parallel component of velocity will remain like this. Do we understand this? Yes or no? The parallel component of the velocity will remain constant. Do we understand this? Do we understand this?
Sir.
And the particle will move ahead. And the particle will move along the x-axis in this particular case. What will happen because of this v perpendicular component? Because of this v perpendicular component, this is perpendicular to the magnetic field. Do we understand this? Yes or no? Do we understand this? Yes or no? Because of this perpendicular component, the particle will move in a circle. And if I see what will be the, where will be the center of the circle? V is here, B is here. The center of the circle would be lying somewhere here inside the board. Do we see this? The center of the circle will lie somewhere here inside the board. Do we understand this? Yes or no?
Sir.
So the particle will move along x-axis, but it will also rotate. So it will go like this. Rotate and move forward, rotate and move forward, rotate and move forward. This type of motion is known as helical path. This type of motion is known as helical path. Have you seen a screw? Have you seen a screw? In the screws, you have threads. You have seen that threads on the screw.
Yes,
Yes,
sir.
sir.
Those are helical. You tighten the screw, it rotates, and it also moves forward. Yes or no?
Sir.
That threads are helical in shape. That is a helical path. Do we understand this, or this has gone above our head saying bye bye sir, I'm going sir, bye bye sir, I'm going sir, bye bye sir, I'm going sir?
Understood, sir.
This type of motion, and I now shall show you a snapshot. This is known as the helical path of an helix. Helical path. Rotate and move forward. Rotate and move forward. Rotate and move forward. We understand this?
Yes.
The radius of this helical path, my dear friend, this is the radius of this helical path. The radius of this helical path will be given by m into v perpendicular divided by qb. Do we understand the significance of v perpendicular here?
Yes, sir.
Because that is the velocity which is perpendicular to the magnetic field. Therefore, in the radius, that velocity will come, my dear friends. Yes or no? No, yes. First listen to me, then I'll give you enough time to write. We understand the radius of the helical path, yes or no?
Yes, sir.
It is moving in a circle, so there will be time taken to complete one revolution. That will be known as the time period of the helix. How much will be that time period of the helix? Remember, it does not depend on velocity, so it will still remain 2 pi m by qb. Do we understand this?
Yes, sir.
It does not depend on the velocity, my dear friend. It does not depend on the velocity, my dear friend. Omega for this will remain qb by m. Do we understand this, my dear friends? Nothing
Yes,
has
sir.
changed on this front. Nothing has changed on this front. But you see one thing that is written here, and I will highlight it. P, pitch. 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 It is not the cricket pitch. The pitch is the distance moved by the helix in one complete rotation. Do we understand this? Yes or no? No, yes. So if you rotate your screw by one complete rotation, how much the screw moves ahead or moves forward, that is known as the pitch. Not the cricket pitch, not the pitch of Shark Tank. It is the pitch of the helix. Do we understand this pitch of the helix? Huh?
Yes, sir.
Pitch of the helix, denoted by the legendary letter P, pitch of the helix. The pitch of the helix is the distance traveled by the helix in one rotation. And how do you find this distance traveled by the helix in one rotation? You multiply this v parallel by the time period. Do we understand this? Yes,
Yes, sir.
or no?
Yes, sir.
Everyone has understood this helical path?
Yes, sir.
Now I shall give you 2 minutes to note down whatever things are there. If you don't understand anything, please let me know. Okay, then this is all about helical path. There are one or two more things that you must remember. Remember, this helical path also has circular motion involved in it. So sometimes when someone says one rotation of helical path, the angle it will turn will be 2 pi, and the time it will take would be 1 turn or 1 pitch. The distance traveled would be 1 pitch. Do we understand this?
Yes, sir.
Then the next thing, sometimes they may tell you the number of pitches it has. Number of pitches is nothing but number of rotation. It is number of repetitions or number of helical turns. Everything is same. Do we understand this? Then sometimes they ask you what are the number of pitches in a given length L. So L divided by the value of one pitch, and the time required will be L by V cos theta. I have seen a couple of questions based on this, and that is why I'm giving you these values. I hope you understand them and that you will note them down. You have 2 minutes to do this one. Then, sir, there comes a question from IIT-JEE of 1995, 1 year before my JEE. And this is a question, it might require some calculation, but you have to be quick in calculating and give me the answer. Everything is given here. Read it once, solve it, and give me the answer. One option correct type question. You have 2 minutes to get to the answer. You have got a proton of mass and charge. The speed is given, it is projected at an angle of 60 degrees to the x-axis. There is a uniform magnetic field of 0.104 Tesla, which is along y-axis. What is the path of the proton? You have 2 minutes to give me the answer. Option C is exactly correct. The particle is thrown like this. Remember, the angle between V and B is 30 degrees. You just have to find, obviously it has to be helix, so you just have to find out the radius and the time period, whatever you feel comfortable, you can find out. And remember, you have to solve it in the quickest possible way. The radius is mass 1.67. Don't have to worry about the powers because everything will just boil down. Everything is given in meters, so don't worry about the powers. M into V, V is how much? 2 into sine theta is half divided by Q into B. Q is 1.6 into B is 0.1. You just do this much and you will get your answers, correct? This will go, this will go, this will go, and you will end up with 0.1 meters. I'm not using the units and all. Do you understand this?
Yes, sir.
You just have to get to the right answer in the quickest possible
Yes,
way.
sir.
To get the time period 2 pi m by qb, you don't have to find out the time period once you have found out the radius because it is useless of finding out the time period. Do we understand this? So this has gone above our head, saying bye, 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 and bye, bye.
Yes, I understand.
Okay.
Sir.
Okay, sir.
Now this was the motion of a charged particle in a magnetic field alone. But in most of the cases, what can happen is you can have a combined electric and magnetic field. We call it electromotive or electromagnetic, not motive, electromagnetic field. It can be a combination of electric field and it could be a combination of electric as well as magnetic field. How will you find out the motion of the particle? In that case comes the last character here in this particular section, Lorentz force. Lorentz force comes into the picture whenever you have a combined magnetic and electric field, or even if you don't have combined magnetic or electric field, you only have an electric field alone or magnetic field alone. The force on the charged particle is given by this Lorentz force. And what is this Lorentz force? F vector, the force acting on a charged particle, is given by this QE plus Q V cross B. The first term, the yellow term, you can understand it is the electrostatic force. The second term, the blue term, is nothing but the magnetic force. So basically, you just add both of these forces vectorly and you get your answers. Do we understand this? Yes or no? You will hardly get any question on Lorentz force. If you get a question on Lorentz force, it would be very simple. The electric field would be given in vector form. The magnetic field would be given in vector form. The velocity would be given. You just have to multiply Q with E and Q with V cross B. We know how to do it. Yes or no?
Yes, sir.
What we can do is some special cases and which are more likely to come in your exam, JEE Main or JEE Advanced, both. We can do some special cases where we can find out what type of motion this particle has. We may not be very concerned with the equation of the motion, but we are more concerned is what type of motion it will have. Case number 1. Case number 1. V is parallel to E is parallel to B. Both all the three gentlemen are together. Something like this. The particle की velocity, electric field and magnetic field are all in the same direction. What will happen? What type of motion this particle will have? What type of motion this particle will have in this case? What type of motion this particle will have? Yes? Huh? No one knows this? What type of motion this particle will have?
Linear.
As you can see, the velocity of the particle is parallel to the magnetic field. Therefore, the magnetic force will on it will be zero. Yes or no?
Yes, sir.
Only electrostatic force or electric force will act on the particle, and because of that, the particle will have acceleration, but that acceleration will also be in the same direction. Yes or no?
Yes, sir.
The particle will move in a straight line. This is straight line accelerated motion. Yes or no? No or yes? The motion will be in a straight line and it will be accelerated. Do we understand this? Yes or no? No or yes?
Yes, sir.
So the particle will move in a straight line and its speed will keep on changing. First, understand, then I will give you enough time to write. So the particle will move in a straight line, straight path, and the speed will be changing. Yes or no? No, yes. The direction will not be changing. We understand this, or this has gone above our head saying bye bye, bye bye, bye bye. We understand this. Or this has gone above our head saying bye bye. The momentum, speed, velocity, kinetic energy, all will change in magnitude, not in direction. The particle will keep on moving in the straight line. You understand this, yes or no?
Yes, sir.
You have 2 minutes to give me to write down this case. So this was the first case. All three are parallel. It was very easy to understand. Case number 2. Do it fast. Second case. E is parallel to B, which is perpendicular to V. What? You have your x-axis and you have your y-axis. Your velocity is along y-axis and your electric and magnetic field are both along x-axis. So your electric field is along x-axis, your magnetic field is along x-axis, but your gentleman velocity is along y-axis. What type of motion this will have? Now, because of electric field, it will have an acceleration in the x-axis, yes or no?
Sir.
Because of magnetic field and the velocity at an angle 90 degrees, it will move in circle, yes or no?
Yes, sir.
It will move in circle, but it will also move forward. But when it is moving forward, it is accelerating. So this will be a helix with increasing pitch. Pitch will not be constant because velocity in the x-axis is increasing. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
So this will be helix with increasing pitch. I am assuming that this is a positive charge. This is a helix with increasing pitch. I'm assuming that this is a positive charge, so velocity will keep on increasing in this direction. Do we understand this? Yes or no?
Yes, sir.
Case number 3. Just a simple variation of this case. E is parallel to B and they are at an angle to V. So basically what I mean to say here is, this is your x-axis, this is your y-axis. Your velocity is like this at an angle. Your electric field is like this. Your magnetic field is like this. Electric field is like this, ding, 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 ding. Magnetic field is like this, ding, 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 ding. But your velocity is like this, ping, 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 ping. What type of motion will this particle have? This velocity can be resolved into two components. One is the x component and one is the y component. Yes or no? Yes or no?
Yes, sir.
Because of y component and magnetic field, it will rotate. Yes or no?
Yes, sir.
Because of x component electric field, it will move forward with increasing velocity. Yes or no?
Yes, sir.
So this will also be same. This will be helix with increasing pitch. Do we understand this? Oh, this has gone above our head saying bye bye.
Understood, sir.
Bye bye. Bye bye. Give you 2 minutes to note this down. Case number 4, a very special and interesting case. And not all the cases will be like this, but this is a very special case. E is perpendicular to B is perpendicular to V. All of these three gentlemen are perpendicular and perpendicular in a very special way, and the velocity and everything is very special here, and you will have to understand it. So I am making it big like this. A very special case. You can see a charge q moving with a velocity v. The velocity is in this direction. Do you see the blue direction? Huh? Are we there or we have lost hidden dimension or gone to celebrate Makar Sankranti? We're all there, right?
Sir.
Particle is moving like this. I have created an electric field in the upward direction. And because of this electric field, you will have electric force in the upward direction because I have assumed that this charge is positive. Yes or no?
Sir.
And then I have created a special magnetic field, green magnetic field, which is coming out of the plane of the board. Now, if I find out the direction of magnetic field, it is V cross B. The direction of magnetic field, magnetic force will be downwards. I could create a case where this electric field and magnetic fields are equal. Can I do that? Yes or no? I can create a very special case where this electric force and magnetic force are both equal to each other and opposite to each other as well. In that case, what will happen, my dear friends? This Q into E will become Q into V into B into sine theta. And here theta is 90, Q and Q getting cancelled. I will get the velocity as E by B. And in this case, even though they are electric and magnetic fields both present, the particle will move in a straight line because both are cancelling out each other. So this is a very special case where even though electric and magnetic fields are present, even though they are not in the parallel direction, the particle is still moving in a straight line. Do we understand this special case?
Yes, sir.
Everyone understands this special case?
Sir.
Pakka, sir?
Sir.
I'll give you 2 minutes to note it down. So this is a question from your favorite book, sir. I don't want you to get caught in the calculation part. So what I'm going to do, a proton goes undeflected in a cross means perpendicular. Electric and magnetic field, the fields are perpendicular to each other at a speed. So you can take, I just want the algebraic answer. You can take the mass of the proton as m, the charge of the proton as q, the speed of the proton as v, the velocity is perpendicular to both the magnetic field. When the electric field is switched off, the proton moves in a circle of radius. This radius can be taken as r. Find the magnitudes of electric and magnetic fields. So your answer should come in terms of m, q, v, and r. Do we understand the question? I don't want you to get into calculation part. That is useless. We understand this, yes or no?
Sir.
2 minutes you have, sir. Basically, I am not going to get into all that. I'm just going to use simple things, use R, M, Q, V, N, and give you the answer. When the electric field is switched off, it moves in a circle of radius R. I know R is equal to mv by qb, yes or no?
Sure.
From here, I can get the value of magnetic field. What will be the value of magnetic field? mv by qr, yes or no?
Yes, sir.
Yes or no?
Yes.
And then when both electric and magnetic fields are present, the particles goes undeviated. So that is the case number 4 that we have done. And I've already given you that v, velocity, will be equal to E by B, yes or no? Huh?
Yes, sir.
So E will be V multiplied by B, and B is mv by qr. So you just put the values, get the answers, and stay happy. We understand this, or this has gone above our head saying bye bye. I'm going bye bye.
Sir.
Question number 46, 47, 48 are questions on these types. I have done question number 48 for you. I will leave question number 46 and 47 for you to do from your SCV, magnetic force wala chapter. You can do that, yes or no?
Sir.
Chalo. I think one question is good enough. Just to tell you the concept. Let us now move on to those questions which are more likely to come, and we will take help of your book. This is this is objective type, and I will ask you to do all the objective type of this chapter. I am going to do some of them quickly, whatever time is left. If you can get the answers quickly, we can move ahead. This is from objective number 1, objective type 1, question number 8. A charged particle moves in a uniform magnetic field. the velocity of the particle at some instant makes an acute angle with the magnetic field. What will be the path of the particle? This is a single option correct question. And I await your answers patiently. Yes, my dear friend. Bacho, what is the answer? No one knows the answer. Huh?
Option C.
Option C. This is a particle moving with a helix in a uniform pitch. We understand this, yes or no? Yes or
Sir.
no?
Sir.
This is question number 9 from the same book, same page. Next question. A particle moves in a region which has a uniform magnetic field and a parallel uniform electric field. So electric field and magnetic field are parallel. At some instant, the velocity of the particle is perpendicular to the field direction. What is the path of the projectile? What is the path of the particle? Yes. Huh? No one knows. No one knows the answer?
Option D, sir.
This is
Option B, sir.
with non-uniform pitch. I've already given you this case. Yes or no? No, yes.
Sir.
Then this is the most difficult type, which is multiple choice. Objective B.
Option B.
Option B. Circle. In this case, circle. How did you get circle? No. You must be wandering in a different universe. Come back to our universe. It is a good universe to live in. This one. I could let me just increase the size of this so that you can see it better. Let me make this ding. Let me make this pinning. If a charged particle at rest, it is at rest, experiences no magnetic force, which of the options is or are correct? Remember, this is a multiple choice correct. So more than one options may be correct. Which are the correct options? Take a deep breath, open your eyes, look at the options, and give me the correct answer.
Sir, option A, sir.
Option A, remember this is a multiple, which is the most different question in a JEE. Multiple option correct. Option A is definitely correct because if there is electric field, it will start to move. Look at the other options. There are other options as well. You are in a marriage party and there are lots of dishes put in front of you. Rasmalai, gulab jamun. I love gulab jamun, by the way. So we have ticked the rasmalai. What about, is there any gulab jamun that you like to have? Anything else that you like? Huh?
Sir.
No, sir. Only rasmalai. Huh? Option D is also correct. The magnetic field may be zero, may not be zero. If it is zero, then also force will be zero. If it is not zero, the velocity is zero. It will not experience any force. And therefore, A and D, Rasmalai and Gulab Jamun, both the options are correct and both the options are like. Do we understand this, or this has gone above our head saying bye bye?
It's understood.
What is the use of understanding when you don't give me the answer? Understanding and not giving answer is of no use. It's a gulab jamun which does not have any what you call that liquid thing. So or gulab jamun, I don't like that. If a charged particle kept at rest experiences an electromagnetic force, reverse of this. So what options? Rasmalai, gulab jamun, jalebi with rabdi on top of it. All three are my favorites. That's why. Or what you children like that pastry with all those ganda things. Yes, rasmalai, gulab jamun, what? Jalebi with rabdi, garma garam, that too hot. Huh? No one. So we don't like all these things, sir. Huh? How long shall I wait? The gulab jamun and the jalebi will get cold. It is winter season. You have to eat it first. Fast.
Sir, option A, sir.
Only one. You only like gulab jamun. What about rasmalai and jalebi? Remember,
Option D, sir.
in a multiple choice question, if you are not confident about the other options, never mark them, because then you will.
Option D, sir.
Option D, sir, may or may not be 0. If it is at 0 also, it will not do anything. It will not 0 also, it will not do anything, because the particle is at. Do we understand this? Yes or no? Huh? Last one. Last option. Last chance to eat your favorite cuisine, favorite sweet dish, rasmalai, gulab jamun, or jalebi with rabdi. I don't know whether you know jalebi. It's a very good dish. Round like this. If a charged particle projected in a gravity-free room deflects, there must be electric field. There must be magnetic field. Must or may are different words. Must. Both fields cannot be 0. Both fields can be non-zero. Deflects, Yes, last option to have your favorite cuisine, and then I will shut this shop. I mean, the party will be over. Marriage party will be over by this.
Sir, options.
Yes, rasmalai, gulab jamun. Which one?
Option C, sir.
Option C, sir. We only like one dish. Both fields cannot be 0. Obviously, there has to be some field which is going to.
Option D, sir.
And option D, sir. Right now, this time we got both rasmalai and gulab jamun in our plates. So congratulations. Jalebi is still left. So all these jalebis are there in your HCV. So I will ask you to have those jalebis and rasmalais when you go back home and you open your favorite book. If you can do all these questions, you are good enough to solve any question that may come in this type. With this, we come to an end of this particular section, the section where we dealt with magnetic force on a single charge. Single charge was there, it was moving. Now it will not be a single charge, it will be a wire of current. Current also has charges moving into it. So now in the next class, we will see force, magnetic force on a current carrying wire. That would be our next topic. I'll see you in the next class. Take care. God bless all of you. Bye-bye.
Yes.